So the first thing is, if this predicate is true, that means we can invoke the method sequence, which guarantee the association invariance and also the invariants are maintained. This is the first thing. And the second thing is, we want to make sure if this predicate is true, the def and use should be executed as well. Two things. So this is exactly what I have written here. So let's look at this one. The user antecedents. Let me go back to the methods. So in this method, I will only do this update if the cardinality of the register is larger than 2. So that's one constraint, that's one precondition. In this case, I will only do this one if the candidate's cardinality is larger than 100. So these are the two preconditions to make sure the def and use are executed. Okay? So that's the first one here. And the two things here are about the association invariance and invariance. Let me go back again. Since we're going to change the candidates, and here, the candidates, this is a magic number I just mentioned, 250. Since we're going to add the candidates number, we've got to make sure it doesn't really exceed its upper bound. Also, the invariance of the students must be larger than or equal to 0. So we've got to make sure when we deduct the balance from the students, he must have enough balance to be deducted. So that's exactly what I have listed here. And now let's pay attention to this expression here. I say the balance, okay, I have the invariance now. The student's balance must be larger than or equal to 0. So if I have this invariance here, so now remember the other magic number I just mentioned, 1600. So balance must be smaller than or equal to 1600. So imagine this. And if we do some calculation, just move the numbers around, the developer will actually notice that this predicate will be false if the cardinality of the candidates is larger than 120. So we are really, what I'm really trying to do is to manipulate the predicates a bit. I have generated testing cases. I will hand it to Paul as the assistant developer. And then this slide is exactly what he's going to interpret the testing cases. He will realize the testing cases is sometimes false. And is this constraint too strong, too weak, or just consistent? I really rely solely upon his intelligence to interpret these testing cases. I won't go to the detail of this one, but this is a method sequence we're interested in, and this is the testing cases we have. And now we rely on Paul to really do the interpretation. And once he interpreted the testing case, he can actually fix the model constraint. He can rephrase his specification model. And I won't go to detail. If you want to go to detail, please I encourage you to go to my paper. And he might decide to actually add one extra invariant such that the constraint I just mentioned can be evaluated to be true. We're just playing around with the predicates. And we can only do this simply because Booster use predicates to represent model operations, which is not possible for Java or C#. Okay, so just some remarks. So our approach does not intend to formally validate that the specification model meets the requirements. We do not intend to do that. It's not possible. What we are really trying to do is to paraphrase the specification model from the data flow perspective. And then we have the method call sequence representing the inter-method usage patterns. And then we have the test suite of predicates for the developer to interpret. And the developers may decide if that's too weak, too strong, or just consistent, and fix it accordingly. Right? So now, for all the slides onwards, it's just how we can implement this approach. I have just applied our approach first in the example, but it's how we do it. I'll just rush them very quickly. And again, please refer to my paper if you're interested. Right? So 3 steps: intra-method usage pattern, inter-method usage pattern, and then interpretation, calculating the constraint interpretation. Okay. So transitionally, each set is a set of locations, and now we want to redefine the 3 sets to be a set of predicates. Okay, that's the formalism of our approach. And we have 3 slides about how we formalize the approach. And I won't go into that, but just pay attention. On the left-hand side, this is the syntax of booster method. And this is the testing case that we can generate, which is a set of Boolean predicates. Okay? And now, for the intra-method usage patterns, we can have 4 categories. Either we just define only, we just use the attribute only, or we can do define and then use, or use and then define. So different patterns. And then, once we have the intra-method usage patterns, we have a table to say how we can compose the methods together. For example, for this one, if we have M1 that defines an attribute, and we have M2 that uses the same attributes, which compose M1 and M2 together to get exactly what I have just shown in the example. And as a final slide for technical stuff, this is a redefining set for def, redefining set for CUs, which is, and both of them are set of predicates. And we can actually draw just any arbitrary member from it, also another arbitrary member from that. So B can actually make sure we will actually go to the def within M1, and C will actually make sure we can go to the usage of the same attributes. If we conjunct them together, we'll make sure we can go def and then use in the method sequence. Right, as the conclusion, I have just mentioned that the context of approach is about information systems, and also we want to preserve the semantics. We specify semantics in terms of formal constraints, and we want the precedence of the semantics. And we want to do model-driven development of booster. And final point is about what I'm really selling here is the booster technology. And the good thing about it is it's declarative and it's formal. And we are trying to adapt the traditional data flow testing into the context of formalism work. Okay, and finally, we really rely on developers' intelligence to interpret our testing cases. And some future work would be just to formalize our approach and then put some good implementation for it, and some case study as well. Okay, special thanks to my colleagues back in Oxford. These people, they helped me read the paper and then give me very good feedback. And that's it. Thank you so much for your patience.
Thank you. Time for questions or comments. The one thing that worries me about this approach is if you automatically collect these constraints, they start getting more and more complex.
Yeah.
And if you plan to present this to the user, my guess the user will have a heart attack. So, I mean, there are constraint solvers, but typically they try to find a solution. Have you thought about, and that might be too specific.
Yeah.
You want something in between, I think. Have you thought about this issue?
I thought about the complexity of the generated testing cases. So there are two things I want to do. Of course, the first obvious thing is to simplify the predicates. Let's say we already simplified it, and now because we are making the assumption that we are only doing simple data transformations for the model operations, because we're not really talking about low-level methods like in Java or C# can be very, very complex algorithms to be implemented. We're just talking about very simple data transformations for the methods. So I will try to answer this question well enough in the next version of this paper. As I said, actually this, I should have mentioned this one because currently if you go to the laboratory website in Oxford University, it's actually specifying Booster, and then the implementations of the website is automatically generated from Booster. So what I want to do is to apply this approach on all the methods available in the Booster model, and then generate it, the testing cases, and hand it to James, the developer of the website, and then ask him to say, okay, James, tell me if these constraints make sense to you. If it doesn't, maybe I'll try to improve the approach of it, or try to simplify in a specific way.
Any other questions or comments? Okay, well, it's time to hand you your certificate. Thank you very much.
Thank you.